A fun fact about Graham's Law is that everyday scents like perfume, sprays, or mist, and cooking in your house or anything spreads across the room because lighter gas molecules like those in the vapor, perfume, diffuse more quickly. Facts I've learned is it explains why you can smell things before you can see them. Graham's law showed that lighter gas molecules move faster. That's why you might smell perfume, smoke, or food before you even see where it's coming from. The lighter scent molecules spread quickly through the air. Okay, my personal overall experience was at first, this project I thought it was gonna be nerve wracking. I thought it was gonna be way harder than what it was. It actually was not that bad. Shout out to my teammates, Ashley and Marie. They're so great. They made it easy, quick. Everything was submitted on time. It was no arguing, fussing, anything. The experience was just great. Most importantly, I was able to grasp the concept of Graham's Law and kind of put it into my own understanding. The easiest part was to add the pictures. That was the easiest part. Everything else was hard. But the hardest part was the research. Because I don't feel like I have a lot of stuff to say about Graham's Law, so you had to really dig and dig and dig and to make sure that we all did not have the same things. So research was the hard part, pictures was the easy part. Because there was not a lot of information provided, I did use multiple sources, including Google. I used a little bit of Wikipedia, even though it's not the most reliable source. Chemistry sites and things like that, all linked on the PowerPoint. One of the original sources I used, I did link it in my PowerPoint as well, was Britannica. It was used for the Thomas Graham's history page, and that was the relevant sciences slide, which is page number 8 on the PowerPoint, or 1.4 part B.
Additional facts that I found on Graham's Law was that hydrogen gas diffuses 4 times faster than oxygen. That's why hydrogen flames are basically invisible, because they burn so fast and so clean. It mixes with oxygen super fast, so it doesn't have a lot of glowing particles, therefore it emits almost no visible light. And hydrogen is the light. My additional interests I found on Graham's Law was I've always wondered why helium-filled balloons deflate so quickly. Like the next morning, they're on the ground almost deflated, while balloons that you air up with oxygen remain inflated for a longer amount of time. This is because helium diffuses faster than oxygen. Even though you think that a latex balloon is airtight, the lighter helium gas diffuses through the small pores in the balloon way faster than oxygen. My overall summary of this project is that it went really well. I was in a wonderful group where everyone worked together and helped when needed. We managed to get all of our parts completed on time. It was very interesting to learn about the diffusion process, and it made me understand so many everyday things like oil diffusers and helium balloons. The easiest part of this project was definitely part E, and the hardest part was making your own problem. I was surprised with how well the videos turned out because I'm not very tech savvy, so thank you Canva for helping me with that.
Okay, my first slide I am going over for part E is interesting facts. Thomas Graham is often called the father of colloid chemistry. He was known for being extremely patient. He once ran diffusion experiments that took weeks just to finish. Other work Graham did was discover the principle of dialysis, still used in medical kidney machines today, studied colloids, creating the early foundation for what became modern physical chemistry, research effusion and diffusion of gases, leading to what we now call Graham's Law. Other scientists connected with his work is John Dalton. He influenced Graham's early chemical thinking, and Thomas Thomson. Graham studied at the University of Glasgow, where Thomas taught and shaped his scientific methods. My second slide would be additional interest. An interesting or surprising fact that I found was I was extremely surprised that lighter gases move much faster than heavier ones, and the math predicting this is extremely accurate. I didn't know Thomas Graham's research led to medical dialysis, which is still studied today for kidney treatment. It was interesting that Graham's law is used in forensic sciences, air quality testing, and even spacecraft atmosphere control. And what I learned versus what I expected. I thought Graham's law would only be a simple formula, but I learned it connects to a real world technology and industrial gas separation. I expected to only learn about gas movement, but I ended up learning about molecular mass, kinetic energy, and why gas particles behave differently. I also learned more about Thomas Graham himself and how important he was to physical chemistry. And what I will investigate further is how modern dialysis machines evolved from Graham's original work. The overall summary of how it went, overall, the project went smoothly. I learned much more than I expected about how gases behave and how Graham's law applies to real situations. The most important part of the most important part was understanding why lighter gases move faster and how this relates to their molar mass. The easiest parts was finding examples of Graham's law in everyday life was pretty easy and interesting.